Example number 6 on first order ordinary differential equations. Solve the differential equation 2x squared dy over dx is equals to x squared plus y squared, given that when x is equals to 1, y is equals to negative 3, isn't it? Now, this is a linear, not linear, this is a first order ODE. So if you look at this, we have more than 2 terms, first term, second term, third term, isn't it? And you can see here we have y on its own, x on its own in 2 terms. So it is hard to use the method of separation of variables, isn't it? Yeah. Then after that you check if it is linear. It is not linear because the power of y is 2. You cannot write it in the form. You cannot write it in which form? dy over dx plus py is equals to, meaning the power of y must be 1. But here the power of y is 2. So it is not linear, isn't it? You go to the third method, homogeneous. Homogeneous is the last thing to check. Are you seeing that? Yes. The first thing to check is the method of separation of variables, which is not working here, isn't it? The second thing to check is whether it's a linear first order ODE, isn't it? It is not in this form. Linear is out. So it means the only thing to check now is it homogeneous. Are you seeing that? Is this an homogeneous ODE? Yes. It is homogeneous first order ODE because the degree of x is the same as the degree of y. There is exponent, isn't it? So how do we solve an homogeneous ODE? You let y is equals to vx, isn't it? Yes. So if you differentiate y with respect to x, you can see this is product rule because v is also a function of x, isn't it? You take v step and you differentiate x with respect to x, plus now you take x step and you differentiate v with respect to x. So in the end, you get your dy over dx to be v plus x dv over dx. Dx over dx is 1, you remain with v. Here is x dv over dx. If you differentiate v, you get 1, you remain with dv over dx. Having done that, it means where we have y, we are going to put vx. Where we have dy over dx, we are going to put v plus x dv over dx. Meaning what we are simply doing here is the substitution process, isn't it? We substitute. So here we have 2x squared into dy over dx, which is the same as v plus x dv over dx to be equals to x squared plus y squared. But y is vx, isn't it? Meaning y squared is going to be what? V squared x? X squared. Because if you square y, you put square on both sides of the equation, you get v squared x squared. The square is for both v and x, isn't it? So having done that, you can see x is common in each and every term. So we divide all through by x squared. You divide all through by x squared, so that goes with that, that goes with that, that goes with that. So what do we remain with here? 2 times v, you get 2v plus 2 times x dv over dx, you get 2x dv over dx. You open this bracket, isn't it? Outside we are left with the 2 multiplies everything inside, isn't it? The other side, this divide by this, you remain with 1. Then plus v squared. So from here you see now your 2v, if you take it on the other side of the equation, you get 2x dv over dx to be equals to 1 plus v squared minus 2v. Are we together? Yes. Can you now separate the variables? Can you now separate the variables? Start. Meaning the v's come this side, the x goes the other side, isn't it? So what are we going to get? 2dv over v squared over v squared minus 2v plus 1 dx over x. Yes. So the whole of this come this side. So here you have 2dv over that, isn't it? Yeah. Dx goes the other side divided by x. Are you seeing we've separated the variables? Are we together? Yes. Having done that, you can see v squared minus 2v plus 1 is quadratic, isn't it? You simply introduce integral on both sides. So what do you get here? 2dv. What is this? That is a quadratic identity, v minus 1, isn't it? Some of these things you just see, you don't waste time with algebra and differential equation, isn't it? Algebra is a small fish in this pond. So you simply know that v squared minus 2v plus 1 is v minus 1 squared, can clearly be seen without doing, isn't it? To be equals to the integral of dx over x. So what is this? There is no v in the numerator, meaning this is automatically algebraic substitution. These two can be taken outside because it's a constant, isn't it? So you see we only have dv over v minus 1 squared. That is, there's no partial fraction there. This is algebraic substitution because we don't have v dv. If it is v dv, then it means you have to resolve it into partial fractions, isn't it? But here we have dv over 1 minus v squared. That is algebraic substitution. You simply say if let u to be v minus 1, if you differentiate u with respect to v, you get du is equal to dv, isn't it? So it means here you are going to have what? dv is the same as du over v minus 1 is u squared. Are you seeing it? So du over u squared is the same as the integral of u raised to negative 2 du, isn't it? Are we together? Are you seeing how that is simple? So if you integrate this, what do you have? You have u raised to negative 2 plus 1 over negative 2 plus. You've integrated that, isn't it? So what do you get? You get u raised to negative 1 over negative 1, meaning it is negative 1 over u. But what is u? v minus 1, meaning in the end you end up with the negative 1 over v minus 1. Are we together? Meaning if you integrate this, you are supposed to get negative 1 over v minus 1. So here we have 2 into, we have 2 into, if you integrate dv over v minus 1 squared, we found negative 1 over v minus 1 to be equals to, if you integrate dx over x, you get ln of x. Then at the end of integration, plus the arbitrary integration constant. Are we together? Are we together?
Yes.
Yes. So after you've done that, you simply substitute back the value of v. So if y is vx, then it implies v is y over. You divide both sides by x to get v, meaning where there is v, you put y over, isn't it? So what do we have here? We have negative 2. 2 times negative 1 is negative 2 over v minus 1. V is y over x, isn't it? To be equals to ln of x plus c. Are we together? See, you can do this. You can multiply the numerator and denominator by x to simplify this equation, isn't it? So that you get negative 2x over y minus the x times y over x will remain with y, x times negative 1 you remain with negative x, isn't it? To be equals to ln of x plus c. So it means the next step is to get the value of c. You'll be told x is 1 when y is negative 3. So what is c? What is c? What is c? Where there is x, you put 1. Where there is y, you put negative 3. So negative 2 times 1, you get negative 2 over y is negative 3 minus x is 1, isn't it? Is equals to ln of 1 plus c. What is the logarithm of 1? 0. Isn't it?
Yes.
Just press the calculator. Meaning this is 0. What do you remain with here? Negative 2 over negative 4 is equals to c because ln of 1 is 0. So this is a clear indication that c is 1 over 2. So where there is c, you put the value of c, 1 over 2. So we end up with 2x over x minus y is equals to ln of x plus 1 over 2. Remember what I'm trying to say. This negativity goes in the denominator. It changes negative y plus x, isn't it? So it is x minus, isn't it? Very simple. Because then you simply have negative 2x over y minus x, meaning this negative can either be in the numerator, it can be in the middle, or it can be in the numerator, isn't it? So you have 2x over negative y, then negative times this positive x, so it changes that, isn't it? Good. So after that, you have solved your problem. Nobody asks you to simplify in which manner you are told to solve the differential equation, and you solve it, isn't it? For you to solve a differential equation, meaning the differential is no longer there. Are we together? And that is how to deal with that problem.